I've tried to record this video like 4 times now, and one of the times it didn't have any sound, so like, this is it. I'm doing this. I don't care what interrupts me. Okay, so today we're going to talk about function notation. It is a concept that is easy, but that you make difficult. I'm also in the hallway, so if you hear extra noise, I'm sorry about that. This is a concept that is actually pretty straightforward, but y'all make it difficult. So I'm going to try and make it as simple as I can for you, okay? So first I want to talk about the different types of things that we see: expressions, equations, and functions. These are 3 different types of representations of relationships, and I kind of want to like help you understand them. So first of all, an expression is a way to represent like a relationship, but it doesn't have an equal sign. And when we just evaluate or simplify them. So to evaluate, I can plug in an x value and simplify that to find out what it's worth. I could like remember when we did combining like terms, so we had like we had like 2x plus 3x plus 7 minus 4, and then we combined our like terms, and we got 5x plus 3. That's simplifying, okay? We can't actually solve it because we can't ever figure out what x is because we don't have an equal sign. We can't say what it's equal to if there's no equal sign, okay? So that's one thing. The second one here is an equation. An equation, by definition, has to have an equal sign. If it doesn't have an equal sign, it's not an equation. So that's an equation. An equation is something that we can solve, meaning we can figure out what x is worth. Now, a function is a type of relationship. So function is also an equation, but with a function, we actually, it gives us a little bit more information. And the reason why we write things in function notation, a lot of people say, like, why are you making it so complicated now? Well, the reason we're making it so complicated is because as we move further along in our math classes and our science classes, we're going to have more complicated equations, and we're going to have more variables. And function notation lets me know what's my input variable and what's my output variable. I got to know what x and y is to be able to graph the representation, to be able to interpret results. So function notation, as I get more complex and complicated equations, lets me tell what those variables are. Okay, so that's what function notation is. That's the difference between expression, equation, and function notation. Now let's get into it and talk about it. So first of all, this expression f parentheses x is actually pronounced f. So f parentheses x is the same thing as y. Okay, let's talk about that a little bit in terms of this function machine. So we have f of x equals 3x plus 5. So first of all, what f of x here tells me is it tells me that right here, this whole function is called function f. Okay, so the name of this function is f. Okay, so that's the name of the function. Now, it's telling me with what's inside the parentheses, this x here, it's telling me that x is my input. So that means I'm going to put x's into this machine. So when you think about the machine, here's what I'm going to think about. I know it's really gross, but think about a meat grinder. So like, this is a meat grinder, and the job, what does it do? It grinds meat. This function, 3x plus 5s. So I take meat, I stick it in the top of the meat grinder, it grinds the meat, and out comes ground meat. So I stick in beef, I get out ground beef. I stick in chicken, I get out ground chicken. Huh? I stick in a tire, I get out a ground up tire. Okay.
Whose deal's the best? Whose deal's the best?
Thank you, Miss Kersey. But whatever I stick in the machine, the rule does whatever the rule is supposed to do and spits out a value. Okay. So f of x says I stick in an x. I stick in an x. It 3x plus 5s that x, and it spits out an f of x, okay? So x is what I put in, f of x is what I get out of function f, whose rule is 3x plus 5, okay? Do you need to know all of that? No, but it kind of helps you understand how it works. So x is the meat, 3x plus 5 is the grinding, is what it does, it grinds meat. F of x is the ground beef I get out. Function f is that this is a meat grinder. Okay, so let's talk about what that means in terms of like why I'm saying f of x. Okay, well, literally it says f of x, and I said f of x is what the output is, right? Well, f of x is y, which is my output. If I rewrite that as y equals f of x, let's talk about how we would say that in English. Okay, well, I would say y is f of x. Well, what does that mean? It means y is a function of x. Literally, they're telling me that this expression here is a function, okay? So we have actually learned one type of equation that's not a function, okay? X equals 5. So a vertical line is not a function. I could not represent a vertical line in function notation because it's not a function, okay? So this right here is what you're going to see a lot when you look at function notation questions, and so this is what you're going to see also. That's literally what function notation is telling us, okay? So let's talk now about like what that actually means, like how can I use that? So let's take a look over here at these examples. All right, so here's what you're going to do with function notation. And this is the strategy, which hopefully works. Actually, I'm going to have to pause real quick and run in and get all right, so the prop I needed was my phone. So I need my, go wherever you're going. So what I need is, so what we're going to do is we're going to make a table, okay? So you see how it says f of x equals 3x plus 4. Okay. Well, remember in my thing here, I input an x, it 3x plus 5 is in it, it spits out an f of x. So that means this is x and this is y. Okay. Well, the f of x, the x is inside the parentheses. So this half of the equation is kind of going to tell me where my x is, and once I get done evaluating this side, it's my y. So what does that mean? Here's what that means. Oh my God, why is my calculator so dark? Okay, there we go. Now we can actually see it. Okay, so I'm going to put 3x plus 4. Actually, I'm going to put y equals. Now, I don't think you can put f of x. I don't. Oh my gosh, I don't know why you would. But we're just going to put y equals 3x plus 4. Okay, and because I'm trying to find values, I'm going to turn that into a table. All right. I did not mean to do that. Yeah, this is my life now. Okay, so 3x plus 4, and then I'm going to say y equals 3x plus 4. I'm going to turn that into a table. Okay, so when I look at this, I'm looking for certain values. So these are inside the parentheses. Remember, inside is my input, it's my independent, it's my x. So when I see a number, does that look more like the left side or the right side? It looks like the left side. So f of negative 5 equals something. F of 2 equals something. F of 0 equals something. F of negative 1 equals something. Okay? So what I'm going to do literally is I'm going to look for those values in my calculator. They're x values. So I don't see negative 5, so down here at the bottom I'm going to put negative 5. Well, when I put a negative 5 into my 3x plus 4 machine, it spits out a negative 11. Okay? I already see 2 on here. When I put in a 2, it spits out a 10. When I put in a 0, it spits out a 4. When I put in a negative 1, it spits out a positive 1. So the calculator is literally that's all we're doing, is we're putting in whatever's inside the parentheses for x, and then we're getting out of the calculator whatever it gives us for y, because at 3x plus 4 got x, and now I've got my answer. Okay. Now let's look at the second column, because this one's a little bit different. Okay, so for this one, instead of giving me what's inside the parentheses, they gave me what's on the other side of the equal sign. Well, I'm going to handle it the same way, and it happens that in this case it's the same expression. Okay, so I still have my 3x plus 4. I'm going to delete some of this stuff to kind of make it a little bit easier for me to do what I want to do here. Okay, so it says f of x equals, so it says something, f of x equals negative 5. So I'm literally f of x equals negative 5, f of x equals negative 2, f of x equals 7, f of x equals 13. So I'm literally looking for what I plugged in to get this negative 5. So let's put in some numbers. So let's start with like, I don't know, it looks like it might be somewhere around there. Like let's say 3. Oh, there we go, 3. I just guessed, okay? So when I plug an x in for 3, when I put an x inside, I get a 13 out, okay? Let's try 2. No, that's 32. That's not it. That's not it at all. Let's do, nope, Let's do 3. Let's do 2. Okay, when I plug in I'm not looking for 10. Let's see what happens next. Hold on, I'm going to get rid of all these extra rows. Okay, oh, look at that. I'm looking for a 7. So when I plug in put a 1 inside, when I plug in a 1, I get a 7 out. Well, let's keep going. 4, I'm not looking for that. I'm not looking for 1. Oh, -2, that's what I'm looking for. When I plug in a -2, I get out a -2. When I plug in a -3, I get out a -5. So literally it's telling me if I put, when I get this out of the machine, what must I have put in? If I get ground chicken out of the machine, I must have put chicken in the machine. Okay? Let's try this last one. Now this one's a little bit trickier because it's got fractions, okay? So this is a whole new expression. I'm going to just completely delete this row. So I'm going to say y equals 1/3. No, that's not it. X. I wish I could get it to turn it into fractions, but it's not doing it. So let's turn it into a table. I wonder if I can gear and have it do it. Nope, it won't do it. Okay, so I need to put the X back. 1/3 X. Okay, so now there's my equation. So now in this case, when I make my little table, I'm going to say f of x equals 1/3 x. Okay? Now, on this one, I see f of -5. Well, that looks like it belongs on the left side. F of x equals 2. Well, the 2 is after the equal sign, so I put it there. F of 0 looks like the left side. F of x equals -4/3 looks like it's on the right side of the equal sign. So now I'm just looking all over this thing. So let's look, first of all. I don't see a 2, but I bet if I keep going, I will. Let's go. There it is. So if I continue, if I just hit enter on my table there, then I see when x is 6, y is 2. Okay? Well, and then here I can see when x is 0, y is 0. I don't have -5, but let's find -5. When x is -5, y is -1.6 repeating, which is actually -1 and 2/3. Okay? Let's look at -4/3. Let's just try some numbers. Well, first of all, what is -4/3 as a decimal? -4 divide 3. -1.33. Well, actually, it looks like we're almost there on this one. Let's try -6. No, let's try -4. There it is, -4. So when x is -4, y is -4/3. So that's all we're doing with function notation. We're going to try not to overcomplicate it, and if you have any questions, let me know.